So here in this, we are going to discuss that there are several approaches and to choose a model. And first we choose a model, and then based on that model, we select different parameters for a model and need to choose that. So the first is select your model, which gives you a reasonable performance, and then you have to adjust the or configure your model parameters. So first step is choosing the model among different models and then setting their parameters. What are model parameters? For example, your learning rate that we discussed, the batch size of your data, we will discuss this, when how many epochs you need, which optimization algorithm, for example, you use gradient descent algorithm for optimizing or updating the weight values. So these are the parameter settings that we have to do. So the first approach is train and test data splits. You can evaluate your model based on that. And the second concept is cross-validation. So we are going to study these two approaches. So first I will dataset partitioning. I will explain dataset partitioning. We already have studied this. I will take it a step further. So your whole dataset is split into training dataset, then your validation, and then your testing data. So these are the partitions. This is 50% nearly, 30% validation, and maybe 20% for your testing. So here your training data is further split into batches. What are the batches? So basically one batch contains 64 data samples. Then the next one, 64 data samples. Next one, 64. Nth batch, 64 data samples. So your whole data set, we know it is composed of data samples. This is how we organize the data in your batches. Similarly will be the structure of your validation data. So if there are 64, you have to set best case 64 data samples for each batch in your validation data as well as your testing data. And then comes the discussion about your training loss, validation loss, and testing loss. So in the training time, what you do is each data sample is given one by one to your training model. First you give your first batch, then you give second batch. Batch means sample number 1 to sample number 64. Batch 2 means 65 to 129, for example, or 128. Batch 3, 129 to onwards. Similarly, your validation data will also be given input like this. Same is the case with your testing data. So at the training time, what you do is you enter your data batch by batch. So for first batch, you have a loss estimated, which we studied was this E of W. You estimate the loss, and then using this loss, you updated your weight values, for example, using gradient descent, learning rate, partial of your loss function with respect to your weight values. So you update your loss at each batch, for each batch, and then what you do is you estimate the average training loss, which is the average of all the loss of batch 1, loss of batch 2, up to loss of batch n. When we have input into our model and update, and each batch will update your weights. So after each batch, your weight values are updated. And we call this, depending on your loss function and estimated loss, and the loss estimation is here is the training loss. So it is estimated per batch. And then one batch, when all of your batches are given as input, whole of this data is given and your models are updated n times, weight values are updated n times because we have n batches. We call this one epoch. When all your data, training data, is input one time and your weights are updated n times, we call this an epoch, one epoch. And after each epoch, we estimate your validation loss. And then, for example, you have 20 epochs, so your model will again be updated 20 times. And every time your weight values will be updated. And after each epoch, you will have your validation loss. Here I would like to mention something. Then for your validation loss estimation, your weights are not updated. It is used just to evaluate your model. Only the model are updated at training time. Only training time. At validation and testing time, the model weights are not updated. And when we have completed the epoch, we will have your test data. When all of the data set is complete, we will have your test data and we can estimate the testing loss where the weight values are not updated. So the concept that we studied here, the training loss and your validation loss. So training loss is estimated per batch and validation loss is estimated after each epoch. We have after each batch, we have your training loss estimation. For each epoch, we have validation. And when we have gone through all the data once, it is done at the end of your training on unseen data. So this is the concept of training loss and testing loss and your validation loss, and how we are going to partition our data. So we can evaluate and train our model on the training data and then test our model. And if the testing is good, the prediction results are good, we can say that model is well trained. So the gap between these two, training and validation loss, should be minimized. That means the model is trained well. And when your model is trained well, you can test it on your testing data. So the question is, how do we choose a good model? Given the data is divided into training and test set, I already told you that the training set and the test set, they should